Empirical research is all about making decisions. During this session, I want to get you really thinking about and working on some of the earliest decisions you will need to make. In research, we make the best decisions that we possibly can with the information that we have in front of us. We keep moving forward, we keep collecting information, and we can often continue to make better and better decisions. You've already made your first decision, and that was what data set you're going to use. The second decision that you made was what variables you want to examine. Now that these decisions have been made and your research question has begun to take shape, it is time to look at the data. Today, you will learn how to call in a dataset and write a basic program that uses frequency distributions to examine your chosen variables. Raw data consists of long lists of numbers and/or labels and are not very informative in that format. Because of this, in order to explore and make sense of the data, we need to summarize that list in a meaningful way. Exploratory data analysis, or EDA, is how we make sense of data by converting them from their raw form to a more informative one. In particular, EDA consists of organizing and summarizing raw data, discovering important features and patterns in the data and any striking deviations from those patterns, and then interpreting our findings in the context of a research question. Working with data that includes more than just a few observations and variables requires statistical software. The use of syntax, or formal code, in the context of statistical software is a central skill that will be discussed in this course. It is a skill that has the potential to greatly expand your capacity, not only for statistical application, but also for engaging in deeper levels of quantitative reasoning about data. As you know, to accomplish this, we will be using SPSS version 21. In the beginning, it may feel like learning another language. As you work through your project, though, it is my hope that you will begin to feel very comfortable implementing the various decisions that you will be making about your data. With all of the windows and views and menus available, it can be hard to know where to start with SPSS. So it is important that you know that, for this course, we will be using only a subset of the features available from this very powerful software package, and that you will not need to learn how to navigate all views and menus. Through video clips and step-by-step instructions, I hope to show you what you really need to know to get started asking and answering interesting questions with data. To start the SPSS program, either double-click on the SPSS icon on your desktop or search for SPSS from the Windows Start menu. Remember that we are using version 21. The first time that you open the program, you will see a blue and white IBM SPSS Statistics version 21 screen. The next screen gives you an empty data editor and the option of opening a data file, typing in data, or running a tutorial. The first time that you encounter this first window, you can simply close it. This will close the window and take you to the default view of the data editor. This main program view, with the menu bar at the top, allows you to access everything that you will be using for this course. In this course, we are using SPSS through the point-and-click approach. This means that we will not be writing SPSS syntax or codes. The point-and-click interface in SPSS allows you to use drop-down menus and select commands that you wish to run. Although we won't be focusing on syntax in this course, it is good to know that SPSS does have a syntax language, which you can learn by looking at the various output that you will be presented with. There are three main SPSS windows: the data editor, which opens .sav files, the output window, which opens .spv files, and the syntax editor for SPS files that we will not be using. Working with data in SPSS and all other statistical software languages requires at least a few basic steps. First, we must call in a dataset that we want to work with. Click File at the top left-hand corner, Open, and then Data. Open the dataset that you wish to use. Here I have just opened the NESARC dataset. The data editor will refresh itself with your data. It is good to get into the habit to sort data according to a variable that uniquely identifies each observation. That is the unique identifier. In the NESARC dataset, the unique identifier is called ID_NUM. To sort the data, go to the Data tab, and then click Sort Cases. Click on ID NUM, and then click the right arrow to put it in the Sort By box. I would like to sort in ascending order, which is the default. Click OK. In the output window, it now tells us that we have sorted by ID NUM, and we can see it sorted here in the data editor. It is important to note as well that the data editor has two tabs, the data view, which is shown here, and the variable view. If we toggle to the variable view, we will see that it is a list of every variable that we have in our dataset, what type it is, numeric or string, and then several other pieces of information, such as whether the measure is nominal, ordinal, or scale. It is important to keep this tab in mind in case we ever need to use it for data management. We are going to begin EDA by looking at one variable at a time, which is sometimes called univariate or descriptive analysis. In order to convert raw data into useful information, we need to summarize and then examine the distribution of any variables of interest. By distribution of a variable, we mean what values and how often the variable takes those values. For example, a random sample of 1,200 US college students were asked the following questions as part of a larger survey. What is your perception of your own body? Do you feel that you are overweight, underweight, or about right? The following table shows part of the data, 5 of the 1,200 observations. Information that would be interesting to get from these data include what percentage of the sample students fall into each category? How are the students divided across the three body image categories? Are they equally divided? If not, do the percentages follow some kind of pattern? There is no way that we can answer these questions by looking at the raw data, which are in the form of a long list of 1,200 responses, and therefore not very useful. However, both these questions can be answered easily once we summarize and look at the frequency distribution of the body image variable. This is to say, once we summarize how often each of the categories occurs. In order to summarize the distribution of a categorical variable, we first create a table of the different values or categories that the variable takes, as well as how many times each value occurs, the count, and finally, and most importantly, how often each value occurs by converting the counts to percentages of the total. Now that we have summarized the distribution of values in the variables that we have selected, let's go back and interpret the results in the context of the questions that we posed. What percentage of the sampled students fall into each category? How are the students divided across the three body image categories? We can see here that 855 students, or 71.3% of the total sample, reported that they felt about right. 19.6% believed that they were overweight, and 9.2% believed that they were underweight. We can therefore see that the categories are not equally divided, and we can also get the exact percentages of each category itself. After sorting, in order to generate distributions for each of the variables you're interested in using to answer your research question, we will be creating frequency tables. I am interested in looking at the association between how much a person smokes, that is the quantity and frequency of smoking, and the presence or absence of nicotine dependence. Going back to my codebook, you may recall that I have selected 3 variables that measure smoking behavior and 1 variable that indicates the presence or absence of nicotine dependence. It is the actual name of each variable, rather than its longer label, that I will need to include in my program in order to generate frequency distributions. I have the names of each of my variables in red. To run frequency distributions in SPSS, go to Analyze, then Descriptive Statistics, then Frequencies. Select Tab 12 MDX, check 321, S3AQ 3B1, as well as C1. Click OK. In the output window, you will now see frequency tables for each of these. Based on the variable names above each table, it is unclear what each of them represents without a codebook. To make this more visually interpretable, I am going to include variable labels with the selected data. At the bottom of the data editor, let's toggle back to variable view. you can see that there are no variable labels listed. I can add variable labels simply by double-clicking in a cell and beginning to type. If I do this and then rerun my descriptive statistics, I will now see the variable label as opposed to the variable name on the top. If I do this for all variables, I will be able to see the frequency tables and the names of each of the variables listed here. When you have quantitative variables, frequency tables are not often the best way to present your data. Instead, it may be more useful to give descriptive statistics such as the mean and standard deviation of a quantitative variable. In order to do this, we go to Analyze and Descriptive Statistics. However, instead of clicking on frequencies, we click on descriptives. Now if I put the S3AQ3C1 variable into the right-hand side and select OK, I will get descriptive statistics that provide the number of valid observations, the minimum, the maximum, the mean, and the standard deviation. When you are running basic descriptive statistics, you will always go to Analyze, Descriptive Statistics. From there, for categorical variables, you will want to click on Frequencies, and for quantitative variables, you will want to click on Descriptives. This will give the most helpful information for each of the variables that you are interested in. The next decision that I want to make is whether I would like to subset my data and ask my questions based on specific observations, or whether I want to ask my question of the entire sample. In other words, are there particular rows of data that I want to keep and others that I want to exclude from my analysis? Since I am most interested in the association between smoking and nicotine dependence in young adults who may still be establishing their smoking patterns, I decide to examine only those adults who are 25 or younger, and exclude all adults that are older than the age 25. I also want to focus on recent smokers rather than individuals who have smoked more than a year ago. Specifically, I now need to run commands to tell SPSS to include only those observations that will help me answer my research question, which I have now further clarified to include the association between smoking and nicotine dependence among young adults who have smoked in the past 12 months. Here are the criteria we set for specific observations that we are using to produce another frequency distribution. In SPSS, we click on Data and then select Cases. Here we need to select if a certain condition is satisfied. To put the optional argument in, we need to click on the If button. This will prompt a new screen. Here we need to enter a specific condition that we want to be satisfied. I only want those variables where check 321 is equal to 1 and age is less than or equal to 25. I will click Continue and then OK. Listed here are the common arithmetic and logical operators used in SPSS, such as those that I used to restrict by age and recent smoking. This is how the data editor looks after selecting cases. You will see on the leftmost side that those rows that do not apply will be crossed out and will not be used in analysis. Those that remain valid will not be crossed out and will be used in analysis. If we repeat the commands for frequency distributions, we will see the frequency distributions for only those selected observations. If we are sure that these are cases that we do not want to use for any analysis, we can delete them completely from our dataset so that we do not have any crossed out rows. To do this, after the Select option, there's an Output option. Here, we want to delete unselected cases. If we click on that, and then click on OK, we will delete from the dataset all those rows or cases that will not be useful for us in conducting our analysis. Notice that I have not changed my research question. I have only decided that I want to ask the question based on only a subset of observations that are available in my dataset. That is, Are smoking and nicotine dependence associated among young adults who have smoked in the past 12 months?